Assalamualaikum warahmatullahi wabarakatuh. Today we will discuss about thermal energy reservoir, heat engines and energy conversion efficiencies. So when we talk about reservoir, we always imagine reservoir is about a large tank. Okay, so in thermal energy reservoir, it means that thermal system with large thermal energy capacity that can supply or absorb finite amount of heat without any change in temperature. The examples of thermal energy reservoir are oceans, lakes, river, atmosphere, and etc. A reservoir that supply heat in a form of heat a reservoir that supply energy in a form of heat, we call it as a source, and reservoir that absorb energy in a form of heat, we call it as a sink. So we can say that thermal energy reservoir is a heat reservoir since they can supply and absorb energy in a form of heat. So as we know, work can always converted to other forms of energy, but converting other forms of energy to work is not that easy. For example, work done by the shaft is converted to internal energy of water. Okay, then internal energy of water will leave the water as a heat. But to reverse the process is impossible. Okay, that is transferring heat to the water does not cause the shaft to rotate. So we can conclude that uh, work can be converted to heat directly and completely, but converting heat to work require the use of some special device that we call it as a heat engine. So, the heat engine is a device that can convert heat to work. Okay, they receive heat from high temperature source such as solar energy, oil furnace, nuclear reactor, and etc. They convert part of this heat to work, usually in the form of rotating shaft, and they reject the remaining waste heat to low temperature sink. For examples, to the atmospheres, rivers, and etc. They operate on a cycle. Heat engine and other cyclic devices usually involve a fluid to and from with heat is transferred while undergoing a cycle. This fluid is called as a working fluid. This is an examples of heat engine. Okay, this is the rotating shaft, internal combustion engine and external combustion engine. Okay, next we go to the steam power plant. Okay, steam power plant, we can see here we have a Q in. So in a boiler, we have Q in. So Q in means amount of heat supply to steam in boiler from high temperature. Okay, and Q out, okay, this is at the condenser, amount of heat rejected from steam in condenser to low temperature sink. W out at a turbine, okay, is a amount of work delivered by steam as it expands in turbine, and work in is amount of work required to compress water to a boiler. So we have a work net. What is work net out? Work net out means W out minus W in, and the unit is in kilojoule. We can also define W dot net out as Q in minus Q out. This is the combined cycle that represent the complete heat engine, and this is thermal efficiency. So for heat engine, the desired output is the net output. Okay, so the definition of thermal efficiency is the net output divided by total heat input. So in the terms of equation, okay, thermal efficiency we give as a nu. TH means thermal efficiency. Thermal efficiency is W out minus W in divided by Q in. Or we can simplify by using W net as a Q in minus Q out. So we can get efficiency as 1 minus Q out over Q in. So for the conclusion of this topic, okay, is in Kelvin-Planck statement. It says that it is impossible to develop a device operating in cycle which produce work continuously by exchanging heat with a single reservoir only. Okay, that's all. Thank you.